Hello and welcome to another of NNT's developer tooling walkthroughs. Today we talk to NGD Enterprise's Head of Development Harry Pierson about the latest enhancements for the Neo Blockchain Toolkit's debugger experience and how developers can get started with the new pre-release version.
Okay, so here is this is a sample that I built last summer as part of the run up to releasing mainnet, N3 mainnet. So this is the NFT sample that I built. So it's a kind of silly little sample. In that you're buying NFTs that are represented by members of the Neo ecosystem, right? So, for example, we have I'm trying to say, where have I've got a bunch of these, where'd it go? Oh, there it is. So I've created I'm running this contract here where I've created tokens for Hong Fei, for Eric, and for John Devados. John's my boss, and so I figured I'd be in a lot of trouble if I didn't make one for him. And so for each of these, this is just the batch file that runs for getting the Neo Express file set up. But you can see here it's got a name, a description, and then a link to their image out on the Neo website, which is actually hosted on Azure. But so if I go and I say I want to look at what this experience looks like in the debugger today. So this is the current 3.1 release. Actually, I take that back. It's actually called 3.2. We've actually broken away the debugging versioning in order to support the preview that I'm going to show you here in a minute. Are even number minor patches, 3.2, 3.4, 3.6. These are release branches, release versions. And then for our previews, we're actually releasing out of the odd. So master branch today is 3.3, and if you install the preview, which we will do here in a minute, you get the version 3.3 of the debugger. Mm-hmm. So I'm just going to run the mint operation here, and we can just sort of see a couple of quick things here. First off is storage. You'll notice that for storage, we have these sort of weird little numbers, and the idea of this was that these are actually a 32-bit hash of the key, and this was just done from to keep it short. And it turns out that this isn't very useful. They are in order, though, so I can actually see that for each of these storage records, I have a key and a value pair. And in this case, we have a single byte key and a single byte value. And if we go through and we look up here at the top, we can see here that the prefix of total supply is 0. And of course, there's only one value for total supply. So what this is saying to me is that the total supply of NFTs that have apparently been minted is 3. Now, that's a significant amount of mental work to do, but it's still something you can do in your head. But as you start to look at some of these other operations, like let's look at an actual token. A token is going to be prefixed with 3. So here's a token that this is a byte stream. This is a 20 byte or a 32-bit. This is the SHA hash. This is the token ID, but it's just a byte stream, right? You can't really, there's not a lot of information you can get out of it. Even worse is the actual value. So those, I showed you before the structure, right? There's a structure that represents the token state, right? So there's an owner, there's the name like Hong Fei, the description of his job, and a link to his image. Well, that gets serialized and it's stored in this byte array. So obviously there's nothing I can really look at in this context and be able to say, oh yes, I know what this actually means. What we wanted to be able to do is to be able to provide a much better experience for our a much better experience of this data, so that you could actually decode this in real time, so that you could actually see it when you're running in the debugger. Mm-hmm. It also turned out that we could also improve the experience for code running in memory in the virtual machine itself. So if we step through this code a little bit, this is the mint operation. So it's going to take the values. Like if I hover over here, we can see I'm minting another Hong Fei for this sample. Obviously that's this is a sample, so it's not that exciting. And if we hover over, we can sort of see the name, description, and the image. And if I walk through this, I can see. Oh, well, let's step out of this. We don't need that. We can see the values over here as variables, right? So it can tell you the name. It knows that name, description, and images are strings. It was able to pull that information out as part of the compile process. But what it's going to do is it's going to create this token state operation, which is a structure, a token state object, which right now is null. So if I step through the code to here, lost the structure information. The format we were using to store information about variables is relatively limited. It can tell you that token state is an array, but it can't tell you that it's an array of what. And it doesn't have any way of representing the token state, right? Which is a structure that has, 3 strings and an owner, a 160-bit hash, an address essentially of the owner. So we've lost all that. So when we look at it in the debugger, not only do we say that it's just an array, which it really isn't, it's a structure, but each of those fields is now being represented as a byte string. So we lost all of that type information. So it turned out that we can actually solve both of these problems at the same time by building a new type model. And we can look a little bit at the type model stuff later, but what I want to show is how we can actually get this new experience here in the debugger. So I'm going to stop debugging here, and I'm going to switch over to look at the list of extensions. So this is the list of extensions that I have installed in Visual Studio Code, and it's somewhat extensive. But if we search down, we can see, oh, look, there's the smart contract debugger. And you'll notice it has this little green triangle thing that most of these do not have. That's an indicator that there's a preview release available for this extension. And if we click on it, you'll notice there's an opportunity to switch to pre-release version. So eventually the code that I'm showing you, the experience that I'm showing you will of course be shipping in the actual real debugger at some point. But we want to make sure we work with some of the other language compilers in the ecosystem to get the experience consistent, so that way it works not just for C#, contract for developers, but also Python and Go and Java, etc. So I'm going to switch to pre-release. You can see it's a very difficult, complicated process. You push the button, and you do need to reload because it had loaded the old debugger, and so this very difficult process to reload, where it just reloads the process. Not a very big problem. But now when I go and I click on that same extension, where did it go? Oh, there it is. You'll see now that it has that pre-release tag up here, and we're running on a version 3.3. As I mentioned earlier, all of the minor releases that are odd are going to be pre-releases, and the even ones will be releases. So, for example, the current release is a 3.2. The next actual production release of the debugger will be a 3.4, and 3.3 we'll switch that to 3.5 for our preview releases. So they'll bump by 2 minor versions each time. So the other thing we're going to do for this specific sample is we're going to switch to a different branch. Since this is not the main experience, the new debugger will work with old debug information. So if you're using the current production C# compiler or any of the other language compilers, it'll still work. But if you generate the new kind of debug format, the old debugger doesn't know what to do with it. So here what we've done is we're switching over to a different branch. Now, there's not much difference between these branches. The big difference is we're going to use a different version of the debugger. I'm sorry, a different version of the compiler to generate the debug information. You'll notice up here we have a file called .NET Tools. The C# compiler from Neo is installed as a .NET tool. And this is just a standard feature of .NET. Has been a feature of .NET Core since 3, if I remember correctly, and we're on 6 now, so it's been a while. One of the things that's nice about the .NET tooling infrastructure is you can install tools. They automatically come down from the cloud, and you don't have to worry about they manage all their dependencies. But what's also nice is you can install different versions for different projects. So you can install a global one that's available across your machine, or you can install one that's local to a project. And that's what I've actually done here. And this file tracks all of the local tools. And you'll notice that we have 2 tools installed for this project. One is Neo Express, just the sort of standard version of Neo Express. But then the other is the Neo C# compiler, and this is the package name for that. And you'll notice that it has a very strange version tag. So what we're doing here for versioning is first off, we're adding this storage schema preview. So these are normal C# compiler drops with the new updated debug information being generated. And we're publishing them in a special NuGet repository, and we're giving them this special versioning and this special tagging. So this is a standard versioning way of doing versioning. To give it a name like this, storage schema preview. All of our preview releases, for example, our master branches are all -preview normally. So this is special because we're running this preview over a longer period of time. We're also generating a version number. It's 1,000 plus the number of Git commits since we forked. We are in the process of getting ready the overall Neo ecosystem, to ship a 3.2 in the next couple of weeks. So when that time comes, we'll merge over the 3.2 and we will rev this to be 3.2.1000 and whatever, So the versioning, there's an algorithm for generating this version number. The point is it's always going to be higher than the current version, and it's always going to have this tag storage schema preview. But we automatically get this installed by running, we'll just bring up a command line window here. You get this, you restore this by just saying .NET tool. You actually have to spell tool correctly, restore. And what that will do is it'll go off and make sure that the Neo Express and the Neo compiler are both available. And then the way you invoke this is you actually precede it with the word .NET. So if I say .NET NCCS and give it, say, version, we will see here that it's actually got the version number that we're talking about, the 3.1.1037, etc. So I'm now going to rebuild my project. I had built it before we watched the video. You'll actually notice here that it's doing that restore. It does a check every time to make sure that your local version is correctly up to date. So I'm now building and compiling, and I'm generating and running the Neo Express batch file that generates the checkpoints that we use for all of our debugging and testing. So now I'm going to go back and I'm going to run that same Mint launch config. We're going to debug the Mint operation, and we're going to see how different the experience is. So you'll notice that we haven't actually changed any code. I'm lying a little bit. There's a very, very tiny amount of code that has changed, and I will show that to you between the two branches. But 99% of this code is the same. But the first thing we're going to do is before we're stopped here at the beginning of the Mint operation, is I'm going to open the storage folder, and you'll notice here we have a very different experience. We do have a slight bug where we have this extra comma. We will ignore that. That will get fixed at some point. I just haven't gotten a chance to do that. So right off the bat, you'll notice here that we have total supply, not just some hex value. And we see that it's actually the value 3. And if we hover over it, we can see, oh, that's an integer. The hash needs to be pulled off. That's a tag that's used in the debug information to indicate that it's a built-in type. Because one of the things about, as we will see as we go through this, is not only does this support the set of built-in primitives like integer and address and hash 160, it also supports extensibility. So I can actually, we'll be able to see things like the token state decoded here. In fact, if we open up the tokens variable, we'll see here, we've gotten rid of those 32-bit hashes and replaced them with the actual key. So this is a 32-bit key. The way it's stored in storage, there's a prefix, and then there's this value. But we've actually just decoded it down to the value. We've extracted up. We use the prefix to tell, this is part of the tokens collection. And if I expand this, well, now we're actually looking at the actual structure of the data. We can see that there's owner, and it's a hash, and we have a name, a description, and an image, which are all strings, and it's automatically decoded them. So what the debugger is doing is it knows what the storage looks like. It knows that the tokens collection, the storage group, has in fact, you might be able to see there's a little, it's probably a little hard to see, but there's a tooltip that says token ID hash 256, which is then a pointer to token state. So what this is basically saying is that the key of this value is a 256-bit hash, a SHA-256 hash, which is what uses the token ID, and the value is the token state. We can actually get 3 different experiences here for different types of storage. So you'll notice here for something like total supply, token ID, and contract owner, there's only a single value, right? There's only one owner of the contract. There's only one current total supply. There's only one next token ID. So for those, we don't actually have any, we just have the prefix. We don't actually have any additional key information. So we just can render that as a single value. For something like tokens, we're storing that as a storage map. So there's a prefix. In fact, if we were to look here at the code, you'll notice here that in the code below, there's a storage. This is the code that's actually going to save this token that we're minting. It's going to say, I'm going to create this prefix, and then I'm going to serialize the token ID, which it's generating here as a 256-bit SHA-256 hash. So when it gets stored, it stores the prefix token and the token ID. It combines into one long key. But what the debugger is doing is it's actually decoding that so that you can see it in the debugger the way that you would expect it to be seen, so you can actually see the actual domain data structure that you've stored. And so we get that for tokens. We also get that for balances. Now, this is interesting for balances. If we look at the owner here, we see that this is all zeros. This specific contract chooses to store NFTs in a single structure, and the owner of that structure is represented here is one of the fields, but it uses all zeros for the representation of a lack of owner, right? So nobody has bought, because this is, a demo, nobody has bought any of these tokens. All three of them have no owner, right? They all have all zeros. But you'll notice here, we're actually rendering that slightly differently. We're actually rendering this as an address. Now, it turns out this is not a valid Neo address, N00000 whatever, because N000 whatever, 0 is actually not a valid character to be used in a Neo address. Neo addresses are encoded using base 58. They're designed to be written down, and they exclude a bunch of characters that can be mistaken for each other. So there's not a lowercase l and a 1. There's not a 0 and an O. So what we're doing here is we're encoding the all zeros specially in a way that's not a valid Neo address, but looks like a valid Neo address, so that the user can tell right away, this is the all zeros one, since that's usually used for something special. If you actually had rendered this as a, I'm trying to think if I have an example of one. I do. I don't think so, actually. Yeah, no, I don't actually have one handy to demonstrate, but if it was an actual address, if that was a valid address, it would actually render it correctly, even down to the character at the beginning. I'm not sure if the audience is aware of this, Edge, but the first character can actually be configured. It was A for Neo Legacy, and it's N for Neo. That was, of course, for Ant shares. And for an N3 and beyond, it starts with an N. But if you're running your own instance of the blockchain, you can actually pick a different character. So it actually does that rendering correctly. Of course, here, 90% and 95% of the time, people are just running, they want to deploy to mainnet or testnet, so they're using these N prefixed addresses. Anyway, so you can see here that we're actually rendering the address special, which is really convenient, because that means that instead of seeing the value here, like you can see the contract owner, this is also an address. This is something that should be rendered as an address. But we haven't actually added, for the preview yet, we haven't added a way to specify a field like here to be an address. We can only do it for keys, and we'll get to that later, but we just haven't gotten to it yet. So eventually this will actually get rendered as an address as well. Now, the last thing I want to show you over here in the storage space is account tokens. Now, account tokens is actually kind of strange, because it has the way that account token, you'll notice that this is rendering very differently. So we have things like total supply and token ID, which only have a single value. And then we have fields like balances and tokens, which are sort of have a single key and then a value that's associated with it. Account token actually has two keys, right? It's actually the way that this specific contract works. It's using account token as essentially as an index. There's a method that you can call in the contract called tokens of, which will give you a list of all of the tokens that are owned by a single user. Now, usually we're storing tokens. You can see here, we're storing a token by their ID. So if we know the token ID, we can find the owner. But the tokens of operation has to work the opposite. I need to know the owner, so I then need to go find the token ID from that. An account token works that way. So it basically stores the owner and the token ID together, combines them into a single key. So there's the prefix, the owner, and the token ID. But again, you can see here, we're actually decoding that out so that the user can actually see the individual parts separately. And in fact, we can even see, if you look up here, 75C6, blah, 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 75C6, we're getting the same value here. So we can actually tell that this token ID matches this token ID. In this specific case, the value, the item is 0. It's always 0. It doesn't really matter. The code will automatically, if you say, give me all of the unowned tokens, it'll find all the ones that start with the all 0 address, strip that off, and then just burn the token ID. Again, that's just sort of the way that the contract works. So I think I already said one last thing, but I was wrong. There is one last thing, and that's raw storage. So this is actually the new view for if you don't actually know the storage information. So with this new debugger, if you have a compiler that doesn't generate the storage information, this is the view you'll get. And so this is a little bit more relevant, I think, because this is actually showing the real key as opposed to that hash of the key, which doesn't really have any real value. It does mean you get these really long keys. Like for this account token, you'll notice here we've got the N0 and then the token ID. That's the same as this one here. The value is reversed. You can sort of see here, this ends with 1727. This one starts with 1727. The storage on disk and the storage in memory are reversed, big Indian versus little Indian. So it gets stored slightly differently on disk. But you can sort of see here, this is what the storage key really looks like that represents this account token. Mm. And of course, you're only going to get actual values. So if I look at like this one here is one of those tokens, again, I get the key as a full byte array and the item as a full byte array. So this is very similar to the old storage view. You always get this in addition to the decoded view. One thing to keep in mind here, by the way, is that none of the storage view stuff has any actual modification of the underlying database. We're going to see how you declare, how do you get this, how do you encode this information in the contract so that the debugger can find it. I'll show that in a little bit. But if you get it wrong, all that's going to happen is this view will be wrong. It won't actually modify anything underneath the covers. It is only a declarative experience that's used in the debugger. It will not actually modify the contents of the contract storage at all. Now, the other thing that was really interesting as we sat down to do this is this was the goal we had. We wanted to be able to get this experience in the debugger for storage. But as I showed earlier, there's also some issues around the experience of virtual machine variables, right? We saw that with the token state, that once you assigned it to token state, it knew it was an array, it knew it was a collection, it didn't realize it was a collection of heterogeneous fields, it didn't know the structure of those fields, it could only show them as byte arrays. So if we walk through the code now again, we get back to that token state function, you'll see now we actually see that it's a token state. And if I expand it, I get that same fully structured experience. Again, under the hood, literally nothing has changed. This is the exact same code we saw before, but now we've actually got more debug information so we can actually get a better experience here in the debugger. And again, eventually we want to be able to represent to say this owner is an address. So I don't want to represent it as a hex string. I want to represent it as a Neo address. But again, this is a preview. It's not completely done yet. And it turns out we can actually do this not just for structures like token state, we can also do this for things like arrays and maps as well. So I'm going to I added, for the purposes of this sample, so this is an addition, I added a method called token list. And all that does is it iterates through the list of tokens and adds them to a list and then returns that list to the caller, right? And this is, you can imagine having a function like this that you would use just for the purposes of like, give me all of the tokens or give me all the tokens that are owned by a specific user or something like that. But again, this was primarily there just to demonstrate how how this experience looks in the debugger. So if I walk through this experience, now remember earlier, under the hood, structures and structures and arrays are stored similarly in the virtual machine. Very similar experience. But because we actually know the difference between here, this is a list of tokens, as we walk through this, we'll see here that it's going to say, this is an array of token state that has 0 elements. And if I go to expand it, there's nothing there because there aren't any. So now I'm going to walk through the code and I'm going to grab each value and I'm going to add it to the list. So as I add this to the list, now we see that it's changed to token state and there's a value of 1. And if I expand it, I can actually see that value. And if we go through the loop, go through this 3 total, because I've added 3, we can now see here that, again, we have 3 different values, right? Each of them different, John, Eric, and Hongfei. And we can see here that this is an array of token states. So this is, from the perspective of the virtual machine, this is an array of arrays, right? So there's the top level array tokens, and each element of the array is another array, a structure of token state information. But we're automatically decoding all of that information for the user to be able to see here in the debugger. We've got a similar example here with token map, where we're going to add that information to a map instead. And again, we'll get that same kind of experience here where we actually will be able to see the key and the value separately. So if we'll just we'll set a breakpoint, we'll jump to the end, and we can see here that we have that the value of tokens is a map of 256-bit hashes to token state. If I open each one up, we can see the key. And if I open up the key, I can see the value. So not only are we getting this great experience in storage, but it turned out we were also able to get that same experience for virtual machine items. In fact, it turned out it was the exact same type model under the hood. The only thing we had to do is we actually had to support interop types. So for example, in this specific code, we're using an iterator, and an iterator is a special interop type, and it's an iterator type in the virtual machine is essentially a wrapper around a .NET type of some sort, in this case, an iterator. And so we can't really do anything with it. As you can see, I can't expand it. I can just see that it's an iterator. But that's better than we could get before. Earlier, all we could tell was it's an iterator. I mean, it's an interop, but we don't know it's an interop of what. We don't have any way of being able to specify that. You'll also notice, by the way, that there's under here this array. When we got the value out of the iterator, we cast it to an object array, because when you do an iterator like this, you get the key and the value. It comes back as a 2-item array with the key is the first item and the value is the second item. You'll also notice here that in array, since I've cast it to an array of object, we actually can represent that in the type system too. You'll notice it's marked as unspecified. So when we represent that, we see that it's just a byte array. So it's also possible to have scenarios where you don't actually know what the type is. So this actually is very useful, especially for helping debuggers or helping other programming languages come online. If you're reading in older debugged information, or if you just don't have that type information, especially for a dynamically typed language like Python or TypeScript, you may not have the full type information like you would for a C# compiler. So you can also always say, I don't really know what this is. In this case, we don't know what it is because the developer told us, it's an array of objects. We're going to treat it individually, and then we're going to actually cast the values separately. So we're going to cast this to an array of objects, and then we're going to cast each individual item to its actual value. The first one to a 256-bit hash, and the second one to a token state, which we can also see. I think so we can see here's the token value and there's the token hash. The coolest thing about all of this was, as I said, we could end up using the exact same type model for both storage and for virtual machine types. And there's slight differences, like you can never store an interop type in storage, but generally speaking, it was the same basic model. Some very small extensions needed for virtual machine types. The other thing was, it turned out to be almost trivial to add it to the compiler. So if you do nothing else, if you just take your project, use the new compiler, again, it's in preview today. It will, we will be available, hopefully it's probably going to be sometime after the hackathon. We don't want to change up tools in the middle of the hackathon. But at some point, this will be in the production release. All you have to do is recompile your existing C# code, and you'll automatically get this experience for your virtual machine variables. And then it turns out to be really easy to get this same experience for storage. So let's take a look at what that's going to look like. So if you remember earlier, let's ignore these errors. Let me restart the OmniSharp. That's what's the driving the IntelliSense. We had these earlier, right? The prefixes. So each of these storage groups has a prefix. This is sort of your common best practice in Neo, is that each type of storage, balances, tokens, account information, what have you, has a prefix. And that prefix could be a string. It's a group of bytes. Unless you have more than 255 different types of storage, you probably just want to use a single byte, because of course, as a contract developer, you pay for storage. So you want to make that prefix as small as possible. So this was the way that the storage looked before, is it just had these individual byte values. But now you'll notice I've added some attributes. This is the only code I have added to this branch. I did add the token, the sample, to get an array and to get a map. But for the actual meat of the contract, I changed nothing except for these declarations. So for each of these declarations, I'm telling the code, hey, this constant byte represents a storage group. We're not settled on the name. Storage group is also a concept in NeoFS, so we're a little worried that there's going to be a collision of concepts. But you can imagine that the idea here is that I'm going to store a bunch of related information together in what I'm currently calling a storage group. And the storage group has a consistent prefix. And so for some storage groups. And I'm going to use that term for now, but again, it may change by the time we actually ship. Again, this stuff's in preview. So for example, with total supply, we just specify the storage group and we specify its type. So in this case, we specify the type, it's an integer. We do the same thing for the token ID. This is the next token ID. Every time you mint a new NFT with this with this contract, it generates a new token ID to use as the seed value. And so for here, we just specify, so in the storage group, you specify the type of the value of the storage group. And in this case, they're integers. We also have a contract owner, and in that case, we're storing that as uint160. Eventually, we would like to create this as address, where we actually have a specific alias for uint160 to represent an address. That'll drive the debugger to be able to represent the UI in the UI to say, show this as a hex string versus show this as an official Neo address. And for single item storage groups like storage supply, like total supply and contract owner, this is all you need, is you just specify the storage group. You can also, by the way, as you can see here, you can also change the name. It automatically just takes whatever the value of the name of the constant is and strips off prefix underscore. But if you want to change it, like for example, balance, I want to change it to balances, token, I want to change it to tokens. You could also specify the string that you want to actually use to represent in the UI. Again, as a reminder, none of this has any actual implications of your actual code. It's just driving the debugger experience. So the next thing is you have the idea of what's called a storage key segment. So as I mentioned earlier, the way you typically store data in a contract for Neo, the key is made up of some prefix, right? So that in this case would be whatever this constant is, and zero or more key segments. If you have zero, like for total supply, you can only store a single value. If you have a key segment, at least one, then you can of course store many different items. In this case, this information tells the debugger how many key segments there are, what their name is, and what type it is. And so you can see here that we've actually, because this is for the key segment, we had to define this new enumerated type, storage key segment type. We could add address very easily. So we've done that. So here you can see that for balances, there's a single key segment owner. You know what? Let's do this. Let's open this back up in the debugger so we can actually see this at the same time that we, whoops, clicked the wrong one. So we can actually see this at the same time as we look at the storage. So again, total supply has a storage group, but no keys. So it's only got a single value. Owner, or balance, we're assigning a name. So it's called balances. It's of type integer, like total supply. And then we can actually see that in both cases. We hover there, it says it's an integer. We hover here, it says that it's an integer. We know that it wants to represent this as an owner. We're not actually, because we're only have a single key, we're not showing the name. But if you hover over the value balances, you can actually see that it's owner address pointing to an integer. So you can actually get the full type of that storage group. And then for ones that have multiple storage keys, like you can see here for account token, you just specify multiple key segments. So here we have owner and token ID, address, and a 256-bit hash. If we look at account token, we can see that for each of those, we have an owner and a token ID, 256-bit cache. So all you have to do in order to get this new experience, switch to the new debugger and add this declarative information about how you're actually storing your data in the storage keys so that the debugger can automatically decode them at runtime. And again, this is completely optional. If you don't do this, you can always look at the raw storage view like we saw here before, so which gives you a very similar experience to what you had before.
Excellent. Have you already been in discussion with some of the other communities about implementing this into their own compilers?
I have. I was talking to the NeoPython folks the last couple of days, and I've been talking to the Axe Labs folks about the Java implementation. So I have a PR open that has the specification for version 1 of the debug information. That's without this extra type information. I'm waiting for that to get approved. That's been in production now since I mean, it's been finalized since long before we shipped mainnet, but it hasn't, that format hasn't changed at all, and it's been has been implemented across multiple compilers since before we shipped N3 mainnet. Just waiting for them to approve the PR into the proposals repo. And then I have a second version of that ready to go as soon as the first one gets approved, so I can open up a second PR that has this new format. But it's all fully formatted, fully documented, and I've shared that with the various other language compiler teams. Again, we're in the middle of, we're getting ready for the hackathon, and that's not really a good time to be messing around with new tools. So I haven't really started a big push on that. I'm going to be talking to those folks during the hackathon, but as I imagine they, like me, are going to be spending most of the month of April helping out developers who are building on top of Neo for the hackathon, and we'll have less time to be able to take on things like, implementing the new type system information to provide a better experience in the debugger.
Mm-hmm. Cool. And you mentioned you had a tweet thread that was kind of documenting your process to getting this out there. You mentioned having some kind of other ideas on the best way to provide like the type information for the storage schemas.
Yeah, so the problem here that I have with this, beyond the name that I mentioned earlier, that storage group also is a concept in NeoFS, which I actually hadn't realized when I picked the name. These declarations are completely separate from the code, right? Like there's nothing here that stops me from saying, oh, well, you know what? I'm going to treat this, I'm going to say that this is actually a hash 160, right? And I can compile this and it will still kind of work, except that this is not going to be accurate. I don't remember if it'll display the wrong information, or it'll probably just to say, you know what, that isn't actually a 160-bit hash, so that's going to be different. Again, this is preview, so some of the debugger, some of the error scenarios are not completely fleshed out yet. So let me just finish building here. So now if I go and I look at the token thing, we will see that tokens is actually trying to render it. Yeah, see, so it's got the wrong key. So now I've got the wrong information. So and that's probably not the world's best error. Whoops, key got wrong. That looks like another thing that I need to fix. A better error message. Better
than no error message, hey?
Yeah, better than no error message. That's true. But you'll notice, of course, that it goes to try and represent the first token. It fails, and it doesn't represent that there were 3 of them. So that information is wrong. Now, again, this is a declaration, and in fact, if we go and we look underneath the covers, the tokens, go back up to the front top here, but quite that much of this. The token prefix is 0x03, so we can still see that storage is still, it is actually still there, right? That hasn't disappeared. We just haven't actually represented it correctly. We haven't been able to decode it correctly because the declaration didn't actually match what the code was doing, right? We declared it wrong. Well, so that means as a developer, you have to maintain essentially 2 separate things. You have to maintain the actual code where you actually save and read and write tokens from the underlying data store, and you have to keep this declaration. So especially while you're in development, it's harder to keep those, if they're changing, it's harder to keep those in sync. Like it's fine, it'll automatically, if you add a field to token state, it'll automatically pick that up. But if you change the way you decide to store the key segments or something like that, or if you change it to a completely different type that you're storing, then you have to go back and modify this. And so one of the things that I've been trying to do some thinking about is, could you actually use this information? Let me back up for one other second here. There's declarative code that actually does this, right? So like if you look in the mint function, if I scroll down here, right, here's the code where I'm saying I'm going to create the token ID, I'm going to create the token state, and then I'm going to actually save it to the token, to the storage map. I'm going to create the storage map for the token group, and I'm going to this setter here, this indexed set where I'm using the token ID as the key. This is the equivalent of a put, right? So this line of code right here is where I actually go to save it. So, and you'll notice here that it's taking the state, it's serializing it, and it's using token ID as a key. Now, theoretically, I could try to parse the contents of the logic to look for cases where we're actually saving stuff to storage and try to reverse engineer that. That is a much harder problem to solve than it is to just say, well, if you declare it, now the parsing those declarations is cake. trying to reverse engineer the actual storage logic from the code is much, much harder. You can also see, by the way, here where we're doing something similar with the token ID. As I said, this is used as a monotonically increasing value that's used to drive the to make sure every token has at least one unique piece of identity, which is the ID. So it would be interesting to think through some other kinds of scenarios where you could actually generate or this code that reads and writes from the storage contract, the storage logic based on those declarations. So instead of having two completely separate things, the imperative code and the declarations, what if you just had the declarations and the imperative code was generated automatically? Especially for C#, this isn't as true for other languages. One of the things that Microsoft has been doing recently is a feature called source generators. And so these are like little snippets of code that run during the build process to generate code. So you could imagine a scenario where you actually say, okay, I'm going to read this contract and it's going to have these declarations, and it goes off and it generates the storage logic to read, write, and delete from storage based on those keys. But that's obviously a lot more difficult to actually think through. And I'm not even sure that that's something that developers want, right? So we have to have the information about the storage structure somewhere. The storage, the type information for normal variables was already there, right? That's C# already just works that way. So it was very easy to get that information for virtual machine types. And then this was the sort of the simplest thing I could think of that would really work for doing storage schema information. But I'm very open to hearing other suggestions, both in terms of, you know, we should name it this versus that. We should use this kind of declaration structure instead of that. Like, this is great because it's simple, but it also, in this case, all of the storage stuff has to live in the smart contract file. So if you want to put your storage in a separate file, this approach doesn't work, or at least it would require some changes in the debugger and the compiler to be able to support that. Again, open to making those changes. I just wanted to do something that I knew would work, that would be simple, and that we could then rev quickly during the preview process.
Yeah, I suppose using the actual attributes also makes it easier to do similar things in other languages as well. Because as soon as you're trying to do source code generation or trying to figure out the schema just by going through the code, you know, like different languages are obviously going to be equipped differently to take on that kind of a challenge.
Yeah, I mean, we obviously, the compiler already does go through the code, right? I mean, the original .NET compiler went through the compiled IL. The new C# based compiler uses a library from Microsoft called Roslyn to parse all of this C# code. And I am only looking at, for the purposes of the work that I'm doing with the type system, I only have to look at the types of these variables. But obviously there is actual logic in the compiler that takes all of this imperative logic and converts it to operations that occur against the Neo virtual machine. And we would actually be able to tell, okay, well, we know that, let me find a good example here. We know that, here we are. This line of code, right, when we're looking at the actual Neo VM output, we can actually tell that this line of code is actually calling into the storage system. In fact, if we step through to it, we can actually switch over to the disassembly view, and we can actually see, apparently I have broken the color scheme for this. Whoops. Oh, I know why. Yeah, the color scheme for this is off, but the text is correct. You can see here that one line of code, right? Storage put, I guess we were, I think we were here. Storage put, here. So you can see this comment here. So this line of code, storage put content key ID +1, is represented by these 6 lines of virtual machine code. So load of location, push a 1, add them together. That's this ID +1. Load location 1, load location 0. That's this context and key store, and then does a syscall. So like we can actually go through and tell where are all of the storage get and storage puts. And so we could theoretically try to reverse engineer that structure from that. It's just a lot more complicated way of doing things. And I wanted to get the preview out as fast as possible. And so I didn't do it that way, but it's certainly something to consider going forward. Because obviously the ability to just take your code and not have to make any changes, just use the new compiler, is a really attractive approach. But I don't know how feasible that is yet, because we haven't really tried to tackle that problem yet.
Mm-hmm. Yeah, so any other major enhancements to this once it gets out of preview that people can expect, or is kind of the bones of everything in place already?
Pretty much the bones of it. There's a couple of other small things. We did add, by the way, you'll notice so variables is the virtual machine variables. This is what's running in the VM, and then storage. There's also engine, and so we've added. We actually added gas consumed a while back. We've also now added contract name and contract script hash, so we can actually see what contract I'm actually running in and what's its script hash. So that just seems to be information that's really useful. And of course, like that gas consumed, you'll notice that as you step, that value changes, right? So it's actually pulling the information directly from the system to know how to actually charge these operations. The values that it uses are the sort of default gas charges, and of course the gas charges can be modified. There's a governance page up on on the Neo. The governance page will indicate the current multipliers for storage and other execution costs. These are using the defaults, but if you the way that this is getting storage information is that there's an associated. So Neo Express has an existing feature called checkpoint, where you can sort of save off the current state of the blockchain, and you can use that. It was originally designed so that you could roll back to that for running tests, but you could also then use it to drive the debugger. So for example, when you go and say, like, I'm looking at contract storage here, well, where's that storage coming from? It's coming from a checkpoint. So you can also, like, as you change, I haven't done that for this example, but you can actually sync the Neo Express policy with mainnet or testnet, so that way the pricing is always going to match. I haven't done that in this case, but that is another thing that we've added here, where again, the gas consumed is in production ones now. The contract name and hash are coming as part of this preview work.
Is that the little endian or big endian hash, by the way?
I don't remember. It should be whichever I think it's the little endian. It's not the way that it's stored in data storage. It's the version that is stored in memory. So I'm pretty sure that's little endian. If I remember correctly, it's stored as big endian on disk for sort purposes and little endian in memory for because that's the sort of the default for Intel and for Windows and Linux and these main operating systems that we run on.
Cool. No, that's really excellent. I think there's going to be a lot of developers out there to be very happy to have access to this. I know I've been messing around with contracts and going through the keys and trying to figure out what everything is, and you just got big binary strings. Is it's a bit of a mess. And I know you had the watch feature where you could manually convert a type, but yeah, this is definitely a more elegant solution than that.
Well, and you can still do those types of things, right? So for example, actually that's something else I can show you. That's kind of a cool thing. Let me switch over, because we've also extended all of that. I totally forgot about that. We've expanded the watch window to also work that way as well. So if I set a deployment here, you'll notice, for example, that if I go and I say I want to add tokens, I can add the tokens to a watch window. And of course, you can pick that information up. But I can also then give it information like I only want to look at the first element of the token value, or I want to look at the owner of the token, and I want to cast that to an address. So I can actually, all the casting operators are all still there, though there's less of a need for them now that we can decode this information directly in the view, in the variables list up here. But so I can cast it, but you also notice that I have the ability it has a recursive algorithm now, so that it'll pick up the first token, the stuff outside of the parentheses, the word token, and then it says, okay, well, I know that that's an array of token state, and then you hand it a bracket, and it says, well, okay, then I know you're looking for the in this case, zero indexed, so we're going to get the first item out of it, and then I'm going to use the dot to get the next item. So it has an algorithm, it has an expression. It's not really a compiler, but it's an expression parser, so they can handle arbitrary complicated collections of bracket operations and dot field operations in order to be able to get values. The same thing goes for maps as well. So if we switch back over to the you can see why I added the token map and token array samples, was so that I could easily to test these types of things. Again, if I do the same thing, I add this as a watch, I can do that. And I can, in fact, I can even just go directly here and add an individual item as a watch. I can just say, add that to watch, and it'll automatically, just pull this one off. Again, it's got this really long key, so that's not very convenient. But you'll notice here that all I had to do was to add it as it knows in the variable window what the watch expression is going to be, so that it can just copy and paste it in here for you, and you can expand it out. And again, I can add a dot expression. So if I say dot name, I get Eric and what have you. So I get that same kind of an experience where I can dig into these subtypes or subfields and what have you of the types, not only in the variable window, but also in the watch window. And of course, with the watch window, you also have the ability to do casting operations. I've also been looking, I started to go down a path of looking at adding, these menus are extensible. For example, you'll notice here, this is not this first part over here is the standard debug window or standard debug menu, but that's not a standard Visual Studio Code menu item, the toggle debug view, right? That's obviously a Neo icon. And so I've obviously extended this menu. These menus are also extensible. So where I have like add to watch, copy value, copy expression, I could add my own things. And so one of the things we were thinking about trying to do was to add a, watch as string, watch as address, whatever. But now that we actually have this rich type information, there's a lot less need for it, right? Before, you had to do that in order to really get a decent sense of what the underlying data was. It also, by the way, to show you one other last thing, well, maybe I keep saying one last thing like I'm Steve Jobs or something. I'm not trying to be like that. One of the other things that's interesting here is the we've also extended that casting operation to support a couple of built-in types beyond the primitive ones. So in this code here, what we're looking at is we're going to go check to see to make sure that the person who submitted the transaction is the contract owner. For the again, this is business logic, but only the contract owner of this contract is allowed to mint tokens. That's just the way this one's set up, right? That doesn't mean that's the way it should be. It just is the way for this specific one. And you'll notice here that we're actually going off and getting the runtime script container, and we're casting it to a transaction, right? This transaction operation. And if I scroll up here, you'll notice here that I actually have the transaction now as a view, right? I can see that information where again, and you can see again, this is actually built in, like the definition of a transaction. I've actually got a tool that automatically compiles the C# smart contract framework and extracts all of the types. I haven't got all of them built into the casting window yet, but that's also another thing that you can do is you can actually cast. Again, you don't really need to do that as much here because that was something earlier in the process, because I didn't have the type system wired up in the compiler yet. So I could have just said, oh, if it shows up as an array, I can cast it to a transaction. Like, so I can actually say like TX and tell it, oh, it is a transaction. Now, of course, it already knew it was a transaction, but you'll notice that TX is actually a valid type. There's also block. This won't actually work because I can't actually cast a transaction to a block, but that's also very useful. It'd be nice at some point to have like runtime script containers show up under storage engine so that you can just have access to it at any time and then be able to cast it, automatically as you see fit. That's another thing that we want to add, but again, we're in preview right now. So, so that works for transaction, for block. Those are the two big things that you probably care about. There's also the ability to access. You can get a contract definition, and that's got the whole manifest has got a big type system, so you can actually do that as well. I don't have a demo of that, but it's the same kind of thing.
So is that for if I was going to say do like a dynamic call or something, invoke another contract, exactly. And I could.
If you want to do a dynamic call, in fact, if you look in this specific code, you'll notice here that there's this code right above it is the post transfer. So this is a standard NEP 11, and part of the rules of a standard NEP 11 is when you do a transfer, if you are transferring to a contract, you have to call the on NEP 11 payment operation. So that's what this code here is doing. So I don't have it broken out, so you can't actually see the value. And I'm not sure if this build actually has the definition of the contract information. This is just checking to see that make sure that it's not null. But you could actually, by the time we ship, you'll be able to say, oh, get me the contract definition. And in fact, if we look at the definition of this type, it doesn't want to work. Okay. You see here that see if it'll, no, it's not doing that. Okay, that's a Visual Studio Code thing it's supposed to be able to do. You'll see that get contract, you can see in the IntelliSense that it returns a type of type contract. And if I say, you know, I just say, you know, var C equals, like get contract. If I hover over C, I can see that that's a contract type, and I can say C.ID and C. Actually, you know what? Let's just do this. Let's see if it actually, if I have that in this build. I'm willing to try that. You have to recompile it though. You will notice, by the way, one of the things we've done is we've got we are in fact, not only are we compiling, there's 2 different contracts and a client code in this project, and there's a test project, and there's a Neo Express setup. So we're doing all of that building, you know, in like 20 seconds every time you build. So you can do all of that. So that way you can immediately test each individual piece. So there should be is there a transfer? I guess I don't have a transfer one set up. Buy NFT, maybe? I don't remember. It's been a while since I've been primarily focused on, oh yeah, so this should work. So I'm just stepping through the code. It's doing I'm transferring a token to somebody else, and I don't need that. There's post transfer. Okay, so in this case, I'm buying it, so the transfer is to a person, so the contract owner is not a contract. So I should have picked list is what I should have picked. So the way that this specific demo works, there's 2 separate contracts, the actual token and then like a store. So the list operation should take it to be a, you know, let's just set up a breakpoint on that code rather than having to step all the way through it again. So here you can see, yeah, it does have it. So here I can see the contract, its ID, its update counter, its hash, its nef, and then its manifest. So we can see here we're about to call the demo shop contract, etc. Actually, this is a cool new feature. So I'm going to step into the before you could only debug one contract at a time. Well, here I'm about to call into the on NEP 11 payment of the debug shop contract. Right, we can see here in the engine that we are currently in the Neo contributor token contract. So let's step, boom. Now we're in the demo shop contract. So we actually also have cross contract debugging working as well. You do have to declare that in the launch configuration. You have to tell it where the debug information is for the contracts you're going to call. You don't automatically find it for the contract. If you look at the launch configuration information here, let's see here, by list. So you can see here that when you specify a contract, you have to give it a name. You have to tell it the type so that the Visual Studio Code knows what debugger to use. We're doing a launch. You specify a path to your NEF. And from there, it can figure out, so that's your main contract that you're running. You can use that to also find your debug info and your manifest. And then there's some other things like where's the express file, where's the checkpoint, what's the invoke file we're using. You'll notice down here, there's also stored contracts. So this is basically a list of the other contracts in the system that you might be invoking. And so you just give it a path to the NEF, and it can use that to load the debug information for that as well. So by specifying that, you can also then debug both sides of the conversation. We have some examples of that in this case where we're starting in the contributor token, and then we're going into the debug one. There's also examples, like for example, for buy, we're starting in the demo shop contract, but then we're stepping into the contributor token. So that turned out to be, there's a funny story behind that. It actually just worked. Like literally all I had to do was to add this information to the launch contract. I had implemented it kind of by accident. It was kind of weird. Robert Oshler was asking me about this, and I was trying to go through and figure out what is it going to take to actually make this work. it's probably going to be a lot of work. And it just worked like the first time out. And I was like, that's weird. So that was kind of strange. But that's actually working in main builds as well. That's not just the preview. That should be there across the board. So, it's basically just a place to distribute. In the original legacy implementation, you would actually deploy these contracts. We don't do that anymore. We do check to make sure that your main program that you're debugging is up to date, but we don't do that for all of the stored contracts. We just do that for the main program. But we do use this information to load the debug information. So that enables you to do that cross-contract debugging right out of the box with the debugger as it is.
Oh, that's super cool.
In fact, I believe when I first shipped this sample, all of these ones that have two parts, there was like by listed NFT 1 and 2. So you would debug the demo shop side of it and then the Neo contributor token side of it. And now, of course, we could get rid of all that and then just have the one that allows you to step through both sides of it.
That's a really cool feature. So I mean, that's if I wanted to make now a contract that say interacted with the Flamingo stack, I could grab their contracts, compile them to get the debug info, and then throw them in here and done.
Absolutely.
Awesome. Yeah, really cool. All right. Well, I mean, thank you for the thorough walkthrough. Is there anything else that we've missed, or?
No, I mean the easiest way to get this information right now. Let me just open up a browser window here to show the link to the page here.
Yeah, we'll throw a link to the Get Started guide in the description as well of the video.
Yeah, so if you go to the contributor token sample, which is under NFT Neo contributor token, right? NGD Enterprise Neo contributor token, and it has a link right in the home page, README to the preview branch where these changes live, and then it has instructions for how to install the debugger and run. Again, to run everything I've shown you today, the only thing you have to do manually is install the debugger preview and get this repo, and everything else happens automatically. Like, so once you've actually cloned this repo and switched to this branch, all you have to do is run this build task to build it locally and then start actually running the debugger. That's it. I mean, there's not a lot of setup. You just need the right version of the debugger and you need the right code. And over time, of course, we're going to have more samples. One of the things, I'm doing some Neo ID work right now, and one of the things that I'm going to do as part of the Neo ID work is add these, schema attributes, so that way I can see that information as I'm debugging the contract. Again, similar example to what you were just saying with the Flamingo ones is that I want to be able to walk through the Neo ID contracts the same kind of way.
Awesome. No, that's really cool. Do you dare give us a timeline on when we can expect to see something coming out?
Well, I want to make sure, I don't want to ship this. Like, I feel pretty good about it. Obviously, there's some things, like there's that comma we saw the error message of whoops. That's not exactly a standard way of, that's not, I don't think that's the sort of standard nomenclature for error messages in Visual Studio Code, whoops. But that's a common thing for me to do when I'm sketching stuff out. The big thing for me is I want to have at least one other compiler that I can test this against, other than the one that I updated, right? Especially, like, I don't want it to be something that I did. So that's where I'm looking to the Go team, the Python team, and the Java team. The guys who do Go, obviously, they're also very busy with NeoFS. So I don't know when they're going to be able to get to this, but I've had some really productive conversations already with both the Python and the Java folks about taking this on. And again, we're not going to want to switch these tools out during like the hackathon. Like, the last thing you guys want, the Neo community wants, is like with a week to go in the hackathon, we ship a new version of the debugger and a new version of the compiler. Like, that's, I'm not doing that. I have a bunch of rules. Like, I don't ship stuff on Fridays, right? Because I don't want to have to deal with it over the weekend if I break something. I learned that working at Microsoft. So same kind of thing here, right? I don't want to ship anything. So I'd like to get this out, as soon after the hackathon as humanly possible, but it's going to be gated primarily on, feedback from devs and from, getting at least one other language supporting it other than C#. So that way we can feel confident that the format's right and we're ready to go. I have a sneaking suspicion that we will have, multiple versions, like multiple ways of doing the storage schema information. Like, for example, you can declare the storage schema today, and that's really the only way you can do it. but then maybe in the future, we also have the ability to generate code from those storage schemas. So like, I'd like to also get a little bit of research in on like how that, like, for example, one of the contracts from the Neo ID, there's an assumption I make in the multi-key segment scenario, to get really picky about it. You have to have keys that are of known length, right? So if I have a prefix, I know how long the prefix is. So if I have a 256-bit hash token, or I'm sorry, I guess for the NFT sample, it's a 160-bit address followed by a 256-bit token ID. Well, I can, if I have this big long hash string, I can tell this part is the key, is the address, and this part is the token ID. Well, in this, it turns out that in the Neo ID contract, there's an example where they have basically two strings, and the strings are of variable length. So how do you tell where one string ends and the next string it begins? And they can be varied. Like, so there's no way to actually know that at compile time. So so there's, as we take more contracts in, we're going to learn more about how people are actually storing stuff in the real world. I like to think that the way that we do this in this specific sample is a best practice, but it would be a really bad idea to assume everybody does it that way. I personally have changed from using strings to using individual bytes over the course of my time working in Neo. So I suspect that there are a lot of other ways of doing this that developers use the way that's good for them.
Cool. Nice timing. Yeah, well, I think we pretty much covered everything. So thank you so much for all your time. I'm sure we have some very excited developers ready to test these tools out, and with Polaris getting ready to start within the next few weeks. Yeah, never a better time for it.
What's going on now, right? In fact, I mentioned Robert earlier, GPT for me on the internal Discord. He was pointing out the other day that if you're going to participate, you really want to behoove yourself to participate in the Planathon and the hackathon, because it can, if you win the hackathon, it can mean literally a 50% increase on your up to a 50% increase in your winnings if you participate in the Planathon and the hackathon. So you're leaving money on the table if you win, if you don't participate in the Planathon. So that's you really should, and you've got, I guess it's about another week and a half before the Planathon ends.
Yeah, about that.
Of course, I don't know when you're going to actually publish this, so that's when we're recording it.
Soon, hopefully.
As a reminder, I'm going to be I'll be spending a lot of time on the Discord for the to answer questions about storage schema and about just Neo development in general. So I'll definitely be around to answer questions over the course of the hackathon. For me, the hackathon represents a fantastic opportunity to get feedback from real developers who are using these tools day in and day out, and I can't begin to tell you how valuable that is. We learned so much from the last one that we did, the Frontier, back at the beginning of when we actually, right before we actually launched N3, I guess was when the last one was. So we learned a lot from that. There's some features that I like we need this, so I built this and we shipped this within the course of a couple of days during the hackathon. So if there's something that comes up that's really important, we're willing to take that kind of thing on. And now that we have the ability to ship preview builds at Debugger, that's even easier. Like, there's a lower bar for standard for quality for the preview builds. I can wave my arms and go, yeah, whoops.
Yeah, excellent. So, all right, well, thank you once more. And and again, thanks, for anyone watching, down in the description, you'll find some links where you'll be able to get started with the new storage schema and debugger enhancements. So thanks once again, Harry.
Thank you.